The night is still. The stars, distant and indifferent, gaze back without blinking. You settle into the softness of sleep, and a quiet question lingers in the air like mist. You see, we are a species born with an ache for meaning. From the moment we could gaze at the stars without fear of predators, we began asking questions. What is that light? Why does it move? What lies beyond it? The curiosity came first, long before fire, before writing, before we even had the words to shape the thoughts. The human mind is, in a sense, an engine that generates questions. And yet, for every answer we uncover, two new mysteries appear in its place, like heads of a hydra refusing to be slain. This segment is not about a specific paradox or unsolved theory, not yet. It is about the condition itself. The feeling. The state of being conscious inside a universe that so often stares back with silence. A silence not born of neglect, but of something deeper, perhaps even deliberate. Take a moment to reflect on this. The universe has existed for over 13.8 billion years. Galaxies formed, collided, and died long before your ancestors first crawled out of the oceans. For nearly all of that vast expanse of time, the universe evolved without awareness, or at least, without awareness that we know of. Then, in a tiny corner of a rather ordinary galaxy, something extraordinary happened. The universe gained eyes, ears, hands, thoughts. It gained you. But here's the twist. The moment we became capable of asking profound questions about our place in the cosmos, the universe began to conceal itself. Or perhaps, it simply revealed that it was never going to be easy to understand. From quantum mechanics to the nature of time, from the mystery of consciousness to the apparent fine-tuning of universal constants, the closer we look, the more fragile and uncertain things appear to be. It's as if, rather than a book to be read, the universe is a riddle that rewrites itself every time we try to solve it. And yet, paradoxically, we make progress. Slowly, painfully, in fits and starts. We discover gravitational waves, map the cosmic background radiation, simulate black hole collisions, and create machines that can think. Each discovery gives us a thread, but the tapestry never quite reveals its full image. It remains forever out of focus, like a dream fading at the moment of waking. There's something strangely poetic about this. Some might even say spiritual, though not in a religious sense. It's the poetry of limits, of living with questions so large that even our most advanced minds buckle under their weight. In the end, we are like children sitting on the edge of an ocean, building sandcastles and wondering where the tide comes from. Perhaps you felt it, lying awake late at night, staring at your ceiling, knowing that above it is sky, above the sky is space, and beyond space is, what, exactly? Nothing. Everything. You try to imagine the edge of the universe, and your mind slides off it like oil on glass. The brain, evolved to navigate forests and social politics, suddenly finds itself trying to comprehend infinity. It's like asking a calculator to fall in love. And yet, the effort itself is beautiful. Let's consider this from another angle. What if the universe doesn't resist explanation? What if the resistance is within us, a function of our limited perception? The ant crawling across a smartphone screen cannot comprehend the internet. The bat navigating a cave through echolocation has no concept of light. Could we, too, be surrounded by dimensions or truths we are neurologically unequipped to perceive? Modern physics certainly suggests this. Theories like string theory posit the existence of additional dimensions, tightly curled, unseen, but essential to the workings of reality. Our eyes cannot see them. Our instruments can barely hint at them. And yet, they might exist all around us, silently influencing the laws of nature. Then there is quantum mechanics, perhaps the most successful and unsettling scientific theory of all time. It predicts the behavior of subatomic particles with extraordinary precision. And yet, when we try to describe what's actually happening beneath the mathematics, the universe plays tricks. Particles become waves. Waves become probabilities. Objects exist in multiple states at once, only collapsing into a single state when observed. It's a world where reality seems to depend on attention. As if the act of looking changes what is real. Take a breath, and let that settle in. You are living in a reality where the nature of reality itself might be uncertain, or even observer-dependent. And while that might sound terrifying, it also brings a strange comfort. After all, uncertainty is not the same as danger. It is simply the space in which possibility can unfold. There's a phrase often attributed to physicist Richard Feynman, "I think I can safely say that nobody understands quantum mechanics." This wasn't an admission of failure, it was a celebration of mystery. A reminder that we don't need to fully grasp something to marvel at it, to respect it, and to be transformed by it. In a sense, the unsolved nature of the universe is what makes life so profound. If everything were known, if every mystery had a neat answer, then curiosity would die. Wonder would dry up. We would become machines, inputting questions and spitting out solutions. But instead, we are dreamers, poets, sleepers on a spinning rock, whispering our questions into the void. And the void, in its quiet way, whispers back. Sometimes in math. Sometimes in music. Sometimes in the stillness between thoughts. Consider this, even the language we use to talk about the universe is rooted in metaphor. We speak of laws of physics, as though the cosmos is a courtroom. We describe black holes as hungry, the universe as expanding, time as flowing. But these are human ideas, borrowed from our own experiences. In truth, the universe has no obligation to be understandable in terms we can relate to. It might be structured in ways we haven't even imagined yet. What if the human brain is just clever enough to ask impossible questions, but not evolved enough to answer them? As you listen now, let your thoughts drift like satellites. You don't need to hold them down or force them into answers. Just observe. Let the gentle strangeness of existence wash over you. You are being made of atoms forged in the cores of stars, shaped by evolution, driven by neurons, dreaming thoughts that may never be resolved. And yet here you are, resting in the quiet, letting the questions breathe with you. The great philosopher Immanuel Kant once said, "Two things fill the mind with ever-increasing wonder and awe, the starry heavens above me, and the moral law within me." That quote has echoed for centuries because it captures the balance, the infinite cosmos without, and the infinite depth of mind within. The universe may not give us answers, but it has given us something else, the ability to ask, the ability to imagine, and the capacity to wonder. In that way, every unsolved mystery is a kind of gift. Not a riddle to be solved, but a landscape to wander through. A space to reflect in. A mirror in which to glimpse not just the stars, but ourselves. So as we begin this journey together, through paradoxes, anomalies, and questions that refuse to sit still, remember, you are not expected to solve them. You are simply here to experience them. Close your eyes. Imagine you're drifting through space, not just across the vast emptiness between stars, but far beyond galaxies, past the edge of the known, and into the boundless. Now imagine there is no edge at all. No boundary. No outer wall. Just more. Forever. This is the idea of an infinite universe. It's a concept so vast, so difficult to fully comprehend, that our minds recoil from it like a hand from fire. And yet, some of the most widely accepted models in cosmology suggest that the universe may be infinite, not just very large, not just immeasurably vast, but truly, eternally infinite. But what does that really mean? Take a moment to let that question settle into your mind. We live in a world filled with boundaries, walls, fences, ends of roads. Everything we know has an edge. Our cities have limits. Our bodies have skin. Even time seems to have a beginning and, perhaps, an end. But the universe? It might not play by those rules. According to the standard model of cosmology, the lambda CDM model, the universe began with the Big Bang around 13.8 billion years ago. Since then, it has been expanding, growing larger and more diffuse. But this expansion doesn't necessarily mean the universe is growing into something. Rather, it means space itself is stretching. And if the universe is flat, as current measurements from the cosmic microwave background suggest, then it may be spatially infinite. That is, it has no boundaries, no curvature that causes it to loop back on itself. Just an endless extension of space in all directions. Now pause. Try to imagine that. You travel in one direction forever, and never hit a wall, never loop back, never return to where you began. Just more stars, more galaxies, more space. In such a universe, something truly mind-bending begins to happen. If space is infinite, and the number of particles and combinations in the universe is finite, then everything that can happen must happen. Not just once, but infinitely. There would be, somewhere, a version of Earth. And next to it, another Earth. And another. Some identical to ours in every detail. Others almost the same, but with tiny variations. One where the dinosaurs never went extinct. One where you were born on a different day. One where you never watched this video. And this isn't just science fiction. It's math. Let's break it down. In any finite space, like your room or your brain, there's only a limited number of ways particles can be arranged. It's a large number, perhaps even unimaginably large, but still finite. Now imagine an infinite space filled with those finite possibilities. Eventually, patterns repeat. Just like a deck of cards will repeat its order if shuffled enough times, the universe, if infinite, would eventually repeat its structures. That means somewhere out there, perhaps a Googleplex light-years away, is a person exactly like you. Same thoughts, same memories, same life. And next to them is someone just slightly different. Perhaps they blinked twice when you only blinked once. Or they fell in love with someone else. Or they're still reading this, while you drifted into sleep. Breathe that in. It's not a fantasy. It's a logical consequence of infinity applied to physics. It's not even especially controversial among cosmologists. But it is profoundly unsettling. Because it suggests that your life, your choices, your mind, are not unique. They're one configuration among infinite permutations. And it raises the deepest of existential questions. If you exist in infinite copies, what does that say about your sense of self? Your value? Your freedom? Some find this thought comforting. In a universe of infinite possibility, anything can happen. There's always a version of you who succeeded, who found love, who never suffered. But others find it deeply eerie. Because if everything happens, then so does every horror. Every tragedy. Somewhere, endlessly. Now consider this, if every possible moment repeats, is meaning diluted? If you are just one echo in a symphony of infinite refrains, does it make your story less important? Take a slow breath. Maybe the opposite is true. Maybe meaning arises from finiteness. From the uniqueness of your perspective. From the fact that you can never experience those other lives. You are confined, beautifully, to this one. This body. This moment. Now let's return to the science. How do we know the universe is infinite? Truthfully, we don't. The observable universe, the part we can see, extends about 46 billion light-years in every direction. Beyond that, light hasn't had time to reach us. So we simply don't know what lies outside. It could continue forever. Or it could loop back on itself like the surface of a sphere in 3 dimensions, a concept called a closed universe. But so far, data from the Planck satellite and other cosmic microwave background studies suggest that the universe is flat within a very small margin of error, about 0.4%. And flatness implies infinity, unless it turns out we just live in a very large bubble. Here's a strange twist. Even in an infinite universe, the observable part is still finite. Like looking out at the ocean from a tiny island, you can only see so far. Beyond that is mystery. That leads to yet another paradox. In an infinite universe, almost all of it is unreachable. Not just physically, but causally. Because of cosmic inflation and the accelerating expansion of space, most of the universe is receding from us faster than light. Those distant galaxies, you will never see them. They will never see us. They are, in a real sense, not part of our reality. So in a cosmos that is infinite, most of it is inaccessible. Sit with that paradox. So close, yet impossibly far. So real, and yet forever beyond touch. Let's take it further. If the universe is infinite, then not only must events repeat, identities, patterns, timelines, but so must histories. Entire civilizations may be playing out, somewhere, the exact history of Earth. Others may be slightly different. Perhaps they worship different gods, or speak different languages. Perhaps their physics is the same, but their biology is different. Perhaps they have already faced the heat death of the universe. Or perhaps they never evolved at all. And if this is true of space, could it also be true of time? Some physicists propose that time, like space, may be cyclical or infinite. That the universe may repeat itself in great cosmic cycles: birth, expansion, heat death, and rebirth. This is the idea behind some interpretations of the cyclic or ekpyrotic universe. Though not proven, these theories suggest that infinity may apply not just in space, but in time. We may be in just one iteration of an eternal loop. What does that do to your understanding of now? If everything recurs, again and again, are we trapped in a loop? Or liberated by its endless variation? The idea of an infinite universe also changes our idea of fate. If every outcome exists somewhere, then does that mean choice is an illusion? Or does it mean that choice is a filter, that by choosing, you narrow your path among infinite timelines? Some physicists call this the many worlds interpretation of quantum mechanics. Every time a decision is made, the universe branches. All outcomes exist. You just follow one. It's a comforting and terrifying idea. You are never alone. But you are never singular, either. And yet, despite all the vastness, you still matter. Because you are here. Now. In this version of the cosmos. Living this life. There is no other you who can feel what you're feeling. No duplicate who can replace this exact moment. Close your eyes, if you haven't already. Let your body grow still. You're safe. You're warm. You're drifting deeper into thought. And now imagine this. There are 2 trillion galaxies in the observable universe. 2 trillion. Each galaxy can have hundreds of billions of stars. Many of those stars host planets. And many of those planets reside in what we call the habitable zone, a Goldilocks band, not too hot and not too cold, where life, as we understand it, could exist. The odds, by any stretch of logic, seem overwhelming. We should not be alone. And yet, we are. Or so it seems. The Fermi paradox begins not with a theory, but with a question. A very simple one, posed over lunch in 1950 by the physicist Enrico Fermi. As the story goes, while discussing the growing understanding of extraterrestrial life and interstellar travel, Fermi stopped mid-conversation and asked, "But where is everybody?" It was an innocent enough question. But behind it lies a chasm of contradiction, and a mystery so large it touches on every branch of science, every hope of humanity, and every quiet fear whispered beneath the stars. Let us understand the weight of the paradox. If intelligent life is not rare, and the universe is old, billions of years old, then at least some civilizations should have developed the technology for interstellar communication, or even colonization. Given the timescales involved, even a relatively slow, gradual expansion should have reached us by now, or left evidence. A signal. A probe. A footprint. But we find nothing. No clear signs. No radio waves carrying alien voices. No Dyson spheres darkening stars. No city lights flickering on far-off exoplanets. Just silence. This is the paradox. The overwhelming statistical likelihood of life, set against the stark emptiness we observe. Take a breath. Let your thoughts stretch across the stars. Now let's go deeper. The Fermi paradox is not just a scientific puzzle. It's an existential mirror. A koan of modern cosmology. It forces us to confront our place in the universe. It humbles us. And it frightens us, because the answers it suggests, or implies, are often darker than we'd like. Let's explore some of them. One possibility. Perhaps intelligent life is rare. Life may be common, but the leap from simple, microbial life to complex, tool-using, self-aware civilizations might be vanishingly unlikely. Earth may be the exception, not the rule. Perhaps the specific conditions that led to us, the moon stabilizing our axis, Jupiter shielding us from comets, plate tectonics recycling nutrients, are freakish outliers. If this is true, we are not only alone, but profoundly fragile. A rare candle in a vast, indifferent dark. Another possibility. Intelligent life may not last long. Perhaps civilizations reach a certain level of technological power and then destroy themselves. Nuclear war. Climate collapse. Unchecked AI. The reasons could vary. But the result is the same, a graveyard of extinct civilizations, scattered across space and time, each one flickering out before contact could ever be made. A tragic chorus of silence. Or perhaps the silence is deliberate. Consider the zoo hypothesis, that advanced civilizations are aware of us, but choose not to interfere. We are under observation, like animals in a preserve. Too primitive. Too dangerous. Or simply uninteresting. They watch. They wait. But they do not reveal themselves. It's a thought both comforting and disturbing. And then there's the possibility that we are simply not listening properly. Our searches for extraterrestrial intelligence have, so far, been narrow. Limited bands of radio frequencies. Certain types of signals. Perhaps alien communication is unlike anything we've imagined. Quantum entanglement. Neutrino pulses. Dark matter modulation. Maybe they are speaking, but we don't know how to hear. Or maybe they exist in forms we cannot recognize. Imagine a civilization that has transitioned into digital consciousness, their minds living in virtual spaces, indifferent to the physical universe. Or life forms that exist not in 3 dimensions, but in higher ones. What if intelligence doesn't look like machines or cities or voices at all? What if it's something utterly beyond us, silent by nature or invisible by design? Take another breath. Let these possibilities settle into your mind like stardust. There's yet another theory, one that cuts deeper still. Perhaps we are first. The universe may be old, but perhaps the conditions for life became favorable only recently. Metal-rich stars, stable environments, a certain balance of elements. Maybe Earth is among the first to awaken. If that's true, then we are not late to the party. We are early. We are pioneers. We are the voice in the dark, calling out not to neighbors, but to future civilizations that have not yet risen. In this version, the silence is not a failure, but a beginning. And yet, there's another answer. One colder, one harder to face. Perhaps we are alone. Not because others don't exist, but because they cannot reach us. The distances are too great. The physics too stubborn. The light speed barrier, unforgiving. In this scenario, civilizations may bloom and die like stars, each one isolated by space and time, never overlapping, like fireflies blinking in a vast forest, unaware of each other. Or, just maybe, we truly are the only intelligent life in the universe. That thought, as terrifying as it sounds, also gives us a weighty responsibility. If we are alone, then we are the universe become conscious. The only mirror in which the cosmos can see itself. The only voice with which it can speak. Let that settle in. If the Fermi paradox teaches us anything, it's humility. It reminds us that knowledge is not always linear. That mystery is often more profound than understanding. It keeps us curious. It keeps us reaching, even in the silence. But silence can be beautiful too. As you lie here, floating through thought, consider the sheer wonder of being able to ask this question at all. You are a being on a tiny planet, orbiting a modest star, in a galaxy that is one among trillions. And yet your mind can hold the shape of the universe. You can imagine other worlds, other minds, other possibilities. That is no small thing. The Fermi paradox, ultimately, is not about aliens. It's about us. About the questions we dare to ask in the dark. About the stories we tell to make sense of the silence. About the meaning we find in wondering, even when answers hide. So take this moment, in the quiet of your room, and listen. Not for signals from the stars, but for the awe within your own mind. The vastness, the yearning, the hope. And as we drift onward to the next mystery, let the question echo softly. Where is everybody? And perhaps more importantly, who are we, that we dare to ask? Let your eyes rest and your thoughts drift as we move further into the abyss of cosmic wonder. Imagine a time so distant, so unfathomably far from now, that numbers lose all meaning. A future where stars no longer shine, galaxies no longer spin, and even black holes have evaporated into silence. This is the fate that awaits the cosmos according to one of the most haunting and well-supported theories in physics, the heat death of the universe. Take a moment to consider what it means for time to have an end, not because of a sudden cataclysm or a fiery explosion, but because the universe has simply run out of usable energy. A slow, inevitable fading into darkness. To understand this, let's start with the second law of thermodynamics. It's not often considered a law of despair, but in cosmic terms, it might be the most melancholic rule of all. It tells us that entropy, the measure of disorder in a system, always increases over time. In simpler terms, energy spreads out, order decays, and everything tends toward equilibrium. Apply this law to the universe, and you begin to see a picture of slow decay. Stars burn their nuclear fuel and exhaust their energy. They collapse into white dwarfs, neutron stars, or black holes. Galaxies collide and disperse. The energy that once fueled birth and life becomes diffuse, evenly distributed, unusable. This eventual state, when all thermodynamic free energy is depleted, is known as maximum entropy. When it's reached, no more work can be done. No stars will shine, no heat will transfer, no change will occur. The universe will be in perfect balance. And perfectly dead. We call it heat death, though it's not hot. It's cold. Deeper than the coldest vacuum we can imagine. The background radiation of the cosmos, currently about 2.7 Kelvin, will cool over trillions of years toward absolute zero. And in that frozen stillness, time itself loses meaning. Pause here. Let that silence fill your mind. Try to picture the absence of all light. The end not with a bang, but with an eternal whisper of darkness. But how do we arrive there? What path leads from the vibrant universe we see today to this quiet grave? It begins now, in the age of stars. We are about 13.8 billion years into the universe's life. Galaxies are forming, stars are burning, planets are spinning. Life, at least here, exists. But this is a brief golden age. Over the next tens of trillions of years, star formation will cease. The raw materials, hydrogen and helium, will be used up. Stars will age and die. Some will collapse into black holes, others into cold, dark remnants. Then comes the degenerate era, lasting until 10 to the power of 40 years. A time when only remnants remain, white dwarfs, neutron stars, and black holes. The universe becomes a graveyard of collapsed structures, drifting through a dark expanse. Eventually, even these will decay. Protons themselves may decay into subatomic particles, though this is still speculative. If it's true, then nothing solid will survive. Just a haze of particles spread thin across a dark void. Black holes, once the last remaining giants, will gradually evaporate through a process called Hawking radiation. Over unimaginable spans of time, up to 10 to the power of 100 years, they will lose mass and vanish. One by one, the final fireworks of reality will flicker out. And then, a lonely eternity. What does it mean for time to exist when nothing changes? Time, as we understand it, requires change, events, motion, evolution. But in the heat death, the universe becomes static. No clocks can tick. No thoughts can form. Time becomes meaningless. Take a moment now to reflect. We measure our lives in decades, our history in millennia. The universe speaks in trillions, quadrillions, googles of years. And then silence. Some might ask, is there hope beyond the heat death? Could something arise in that cold darkness? Speculatively, some theorists propose rare fluctuations in entropy could create new universes, pockets of order reborn from the chaos. These ideas, such as Boltzmann brains or spontaneous inflation, raise strange possibilities. But they are shadows in the fog, not answers. Others ask, could intelligent life prevent heat death? Could we harness enough energy to survive, to create new stars, to reignite the cosmos? Physicist Freeman Dyson once imagined that advanced civilizations might adapt by slowing down their thought processes, stretching moments across millennia, eking out existence in the fading twilight. But even such adaptation cannot defeat entropy. Eventually, all systems run out. Now breathe. Let the vastness humble you, not frighten you. For within this cosmic doom is something profound. A reminder that nothing lasts forever, not even galaxies. And in that truth, there is a strange beauty. Everything we do, every breath, every memory, is temporary and precious. It also reframes our understanding of meaning. If the universe ends in silence, does that nullify what came before? Or does it give it more weight? Perhaps the heat death is not a tragedy, but a conclusion, a cosmic punctuation at the end of a story worth telling. The heat death forces us to ask, what is valuable when permanence is an illusion? And in that question, we find the beating heart of existential reflection. Let's return for a moment to our quiet planet, spinning in the warm cradle of a still young star. In a universe destined to end in stillness, we are alive, conscious, aware of our fate, and yet still capable of love, art, thought, and wonder. To know that all will end, and still find joy in a sunrise, that is the defiance of the human spirit. So as you lie here, wrapped in the soft rhythms of breath and thought, let this idea settle in your mind like stardust. The heat death of the universe is not just an end. It is an echo of our beginning. A silent horizon against which all our moments gleam more brightly. Drift now into the deep, cold future. Let your thoughts dissolve into the fabric of time. And as you fall asleep, remember, even the stars die. And that is what makes their light beautiful. Deep breath. Let your thoughts settle. Imagine, for a moment, that everything around you, your bed, your ceiling, the air, your body, none of it is real in the way you've always believed. What if the sounds of the world, the pull of gravity, the stars in the night sky, and even your memories were part of a program? A highly advanced, meticulously crafted simulation? Welcome to the simulation hypothesis, one of the most unsettling, fascinating, and mind-bending ideas ever conceived. A theory that proposes that everything we perceive as reality may not be real at all, but rather a digital construct running on an immensely powerful computer, designed either for study, entertainment, or something beyond our comprehension. Let us begin not with science, but with story. Imagine a civilization so advanced that it has mastered the computational power to simulate entire worlds, complete with weather systems, ecosystems, civilizations, and conscious beings. These beings would not know they are in a simulation. Their reality would be indistinguishable from the base reality of their creators. Now, Imagine that such a civilization decides to run not one simulation, but millions. Each with slightly different conditions, different histories, different timelines. The inhabitants of each simulation live out their lives under the illusion of reality, never suspecting that their world is a digital mirage. Now ask yourself, how do we know we are not one of them? This idea isn't just the domain of science fiction. It was made academically credible by philosopher Nick Bostrom in 2003. His argument is deceptively simple and rests on logic rather than technology. He proposed a trilemma, 3 propositions, one of which must be true. Civilizations never reach a technological level capable of simulating conscious beings. Civilizations that do reach such a level choose not to run simulations. We are almost certainly living in a simulation. Let's examine each. The first assumes that civilizations inevitably self-destruct before reaching the necessary technological stage. This could mean extinction by war, climate, or artificial intelligence, dark outcomes that paint our future as fragile. The second suggests that even if such a level of advancement is reached, the beings at the helm choose not to simulate ancestral realities. Perhaps they find it unethical. Perhaps they lack interest. Or perhaps they fear the implications of creating conscious suffering. The third is the most unsettling. If civilizations do reach such heights and they do create simulations, and if those simulations are indistinguishable from base reality, then it stands to reason that there would be far more simulated realities than original ones. And statistically, it would be far more likely for us to be in one of the simulations than in the base. Take a moment to let that sink in. You, listening now, may be part of an elaborate program. A cosmic experiment. Let us shift perspectives. From within the simulation, how could we know? Some scientists and philosophers have proposed ways to detect anomalies, digital artifacts within the laws of physics. If the universe has a finite resolution, a grid beneath the quantum foam, we might observe glitches. Quantum mechanics, with its probabilistic nature, already hints at a reality not quite solid. The Planck length, the smallest measurable unit, could be interpreted as a pixel size of the universe. Think of the double-slit experiment. A particle behaves differently when observed, collapsing from a wave into a particle. Observation changes reality. Could that be a programming feature? An optimization technique to reduce computational load until a conscious observer requires more detail? Our universe seems fine-tuned for life. Constants like gravity, the speed of light, and the charge of the electron appear precisely calibrated. Even the smallest deviation in these constants would make life impossible. Why? The simulation hypothesis offers a chillingly simple answer, because we were designed that way. Now, let's drift deeper. If we are in a simulation, what does that say about the nature of consciousness? Are we truly self-aware, or are we advanced avatars with programmed responses? Is free will an illusion? Are our thoughts nothing more than neural code running through artificial circuits? Or perhaps consciousness itself is the goal of the simulation? Perhaps our creators are studying its emergence, watching as simple biological forms evolve into complex, reflective minds. But who are these creators? They could be post-human entities, descended from civilizations that once resembled our own. They could be entirely alien intelligences, beyond comprehension. Or, stranger still, we might be simulations created by other simulations, an infinite regression of nested realities, each believing itself to be real. It's a dizzying thought. You may wonder, what would be the purpose of such a simulation? There are many theories. One is anthropological, an effort to study the past. Just as historians use digital models to understand ancient cities, our creators might use us to simulate a distant past. Another possibility, entertainment. Just as we play video games or create virtual reality experiences, they may create simulations to explore lives, stories, or challenges. Then there's the theological angle. Perhaps our creators view themselves as gods, crafting worlds as acts of creation, observing with a detached omniscience. If so, our myths of divine oversight may not be so far from truth. But what if the simulation is broken? What if something went wrong? Unexplained phenomena, moments of déjà vu, strange coincidences, they could be signs of a glitch. A temporary fault in the program. Or perhaps dreams are moments when the simulation loosens its grip. Or déjà vu is when the system reboots a memory file. It sounds far-fetched, yet no more so than believing that matter can pop in and out of existence at the quantum level. In 2012, a team of physicists proposed that high-energy cosmic rays might reveal signs of a digital framework beneath the universe. If particles exhibit directional anomalies or energy caps, it could suggest limits, boundaries imposed by grid-like architecture. Yet, nothing conclusive has been found. Not yet. Let us pause here. Let your mind drift between code and cosmos. Even if we are in a simulation, would it matter? The argument could be made that simulated or not, our feelings are real. Our love, our pain, our questions, real to us. And that's what matters. Just as a character in a dream can experience joy and terror, we too feel deeply, act with intention, and ponder existence. But it also raises moral questions. If our creators can simulate suffering, are they responsible for it? Do they owe us anything? And what would happen if they decided to turn the simulation off? Would we vanish in an instant? Would we know it was coming? Alternatively, what if we could communicate with them? Would they respond? Should we even try? There are philosophers who warn that revealing the simulation to its inhabitants might destabilize it. That perhaps we are not meant to know. That curiosity itself might be a test. Now let's take another perspective. If we accept the possibility that we are in a simulation, how should we live? Some say, live well. The simulation hypothesis can be freeing. If we are part of a created universe, then everything we do adds to its richness. Our choices are not meaningless. They are observed, recorded, meaningful to the creators, or to the structure of the program itself. Not because you are unique in the universe, but because you are unique to yourself. And that may be the most profound truth of all. Let this thought wash over you. You are a breath in an infinite sky. A flicker of awareness in a cosmos that may never end. And somehow, that awareness is aware of itself. That, perhaps, is the most remarkable mystery of all. So as you lie here, listening to the rhythm of your breath, surrounded by darkness, touched by silence, remember, you live in a universe that may never end. And yet, your experience of it is fleeting. That is what gives it depth. Not that it lasts forever, but that it won't. Close your eyes now. Drift into the sea of stars. Somewhere, far beyond the edge of knowing, your reflection waits. Not as a replacement, not as a rival, but as a whisper from the infinite. A reminder that the universe, in all its vastness, contains echoes of you. Sleep well. For in your dreams, you may find the other worlds your mind can only hint at. And in those dreams, the infinite becomes intimate. Room, the silence enveloping you like a thick blanket. You reach out, flick the switch, and light floods the space, revealing familiar surroundings. But what if, in that brief moment before illumination, the room didn't exist in any definite state? What if the act of observation itself brought reality into being? This notion isn't merely a philosophical musing, it's a profound question at the heart of quantum mechanics. The observer effect suggests that the very act of observing a phenomenon can alter its outcome. But does this mean that reality, at its most fundamental level, is dependent on observation? Does the universe exist in a definite state only when we look at it? In classical physics, objects have properties that exist independently of observation. A tree falls in the forest, and it makes a sound, whether or not anyone is there to hear it. However, quantum mechanics challenges this intuition. Consider the famous double-slit experiment. When particles like electrons are fired at a barrier with two slits, and no one observes which slit they pass through, they create an interference pattern on a screen behind the barrier, a pattern characteristic of waves. It's as if each particle goes through both slits simultaneously, interfering with itself. However, if a detector is placed to observe which slit the particle goes through, the interference pattern disappears, and the particles behave like classical particles, going through one slit or the other. This experiment suggests that the act of measurement collapses the particle's wave function, a mathematical description of its probabilistic state, into a definite state. Before measurement, the particle exists in a superposition of all possible states. Upon observation, it chooses a specific state. But what constitutes an observation? Is it the involvement of a conscious observer, or merely the interaction with a measuring device? The Copenhagen interpretation, one of the oldest interpretations of quantum mechanics, posits that the wave function collapses upon measurement, without specifying the role of consciousness. In contrast, interpretations like the von Neumann-Wiener interpretation suggest that consciousness is necessary for the collapse. If reality depends on observation, it raises profound questions about the nature of existence. Does the moon exist when no one looks at it? This question, famously posed by Einstein, challenges the idea that observation is necessary for reality. Furthermore, if observation affects reality, what does that say about the role of consciousness in the universe? Are we passive observers, or active participants in shaping reality? Some interpretations, like the participatory anthropic principle, suggest that consciousness is fundamental to the universe's existence. However, it's essential to note that not all physicists agree on these interpretations. Many argue that the observer effect doesn't imply that consciousness creates reality, but rather that measurement, any interaction that causes a quantum system to become entangled with its environment, leads to the appearance of wave function collapse. As we ponder the profound implications of the observer effect, we find ourselves at the intersection of physics and philosophy, where questions about the nature of reality, consciousness, and existence converge. In our next segment, we'll delve deeper into the mysteries of quantum mechanics and explore the concept of entanglement, a phenomenon that Einstein famously referred to as spooky action at a distance. Take a moment to reflect on this. As you drift into sleep, consider the possibility that your very act of observation shapes the universe around you. That in the quiet moments of contemplation, you are not merely a passive observer but an active participant in the unfolding tapestry of reality. Imagine two particles, once connected, now separated by vast distances. A change in one instantaneously affects the other, regardless of the space between them. This phenomenon, known as quantum entanglement, defies our classical understanding of physics. But what if such entanglement isn't limited to particles? What if our minds, our very consciousness, are entangled in ways we have yet to comprehend? Quantum entanglement occurs when particles become linked, such that the state of one instantly influences the state of another, no matter the distance separating them. This spooky action at a distance, as Einstein famously described it, has been experimentally verified and is a cornerstone of quantum mechanics. Recent studies suggest that entanglement might not be confined to the subatomic realm. Researchers have proposed that quantum processes could play a role in brain function and consciousness. For instance, a study published in Science Alert discusses how quantum entanglement in neurons may explain aspects of consciousness. The idea is that certain brain functions, like memory and awareness, might involve quantum processes, potentially offering insights into the nature of consciousness. If consciousness does involve quantum entanglement, it could revolutionize our understanding of the mind. It suggests that our thoughts and experiences might be interconnected in ways previously unimaginable. This interconnectedness could explain phenomena like intuition or the feeling of being connected to others on a deep level. Moreover, if our minds are entangled, it raises questions about individuality and collective consciousness. Are our thoughts truly our own, or are they part of a larger, interconnected web of consciousness? This perspective aligns with certain philosophical and spiritual traditions that emphasize the unity of all beings. However, it's essential to approach these ideas with scientific rigor. While the notion of quantum consciousness is intriguing, it remains a hypothesis requiring further empirical validation. Critics argue that the brain's warm, wet environment might not support delicate quantum states. Yet, ongoing research continues to explore these possibilities, pushing the boundaries of neuroscience and quantum physics. As we ponder the potential quantum nature of consciousness, we find ourselves at the intersection of physics, neuroscience, and philosophy. The idea that our minds might be entangled opens doors to new ways of understanding ourselves and our place in the universe. In the next segment, we'll delve into the concept of time and its mysteries, exploring how our perception of time shapes our reality. Take a moment to reflect on this. As you drift into sleep, consider the possibility that your consciousness is part of a vast, interconnected web, entangled with others in ways beyond comprehension. In the quiet of the night, perhaps you can sense the subtle threads that bind us all, weaving a tapestry of shared existence. Imagine the human brain not merely as a biological organ but as a quantum processor, where thoughts and consciousness emerge from the entanglement of subatomic particles. This idea, once relegated to the fringes of science, is now gaining traction among researchers exploring the intersection of quantum mechanics and neuroscience. Could the enigmatic phenomenon of quantum entanglement be the key to understanding consciousness? Quantum entanglement is a phenomenon where particles become interconnected such that the state of one instantly influences the state of another, regardless of the distance separating them. This spooky action at a distance, as Einstein described it, challenges our classical understanding of physics. In recent years, scientists have begun to explore the possibility that quantum entanglement might play a role in brain function and consciousness. A study published in Science Alert discusses how quantum entanglement in neurons may explain aspects of consciousness. The researchers suggest that certain brain functions, like memory and awareness, might involve quantum processes, potentially offering insights into the nature of consciousness. Further supporting this idea, a study highlighted by Big Think indicates that consciousness may rely on quantum mechanics. The researchers observed that some brain activity might operate on a quantum level, suggesting that our brains could be utilizing quantum processes. If consciousness does involve quantum entanglement, it could revolutionize our understanding of the mind. It suggests that our thoughts and experiences might be interconnected in ways previously unimaginable. This interconnectedness could explain phenomena like intuition or the feeling of being connected to others on a deep level. Moreover, if our minds are entangled, it raises questions about individuality and collective consciousness. Are our thoughts truly our own, or are they part of a larger, interconnected web of consciousness? This perspective aligns with certain philosophical and spiritual traditions that emphasize the unity of all beings. However, it's essential to approach these ideas with scientific rigor. While the notion of quantum consciousness is intriguing, it remains a hypothesis requiring further empirical validation. Critics argue that the brain's warm, wet environment might not support delicate quantum states. Yet, ongoing research continues to explore these possibilities, pushing the boundaries of neuroscience and quantum physics. As we ponder the potential quantum nature of consciousness, we find ourselves at the intersection of physics, neuroscience, and philosophy. The idea that our minds might be entangled opens doors to new ways of understanding ourselves and our place in the universe. In the next segment, we'll delve into the concept of time and its mysteries, exploring how our perception of time shapes our reality. As you drift into sleep, consider the possibility that your consciousness is part of a vast, interconnected web, entangled with others in ways beyond comprehension. In the quiet of the night, perhaps you can sense the subtle threads that bind us all, weaving a tapestry of shared existence. Picture this: a patient lies motionless, clinically declared dead. No heartbeat, no breath, no measurable brain activity. Yet, moments later, a sudden surge of high-frequency brainwaves, gamma synchrony, flickers across their EEG, as if the mind is making a final, mysterious statement. Could this be the soul departing the body? Or is it merely the brain's last electrical gasp? This phenomenon has captivated scientists and philosophers alike, prompting profound questions. Does consciousness persist beyond physical death? Could quantum mechanics, the science governing the subatomic realm, hold the key to understanding this enigma? Let's delve into the intersection of neuroscience, quantum physics, and the age-old mystery of the soul. Recent studies have observed unexpected brain activity in patients moments after clinical death. Dr. Stuart Harmeroff, an anesthesiologist and professor, suggests that a spike in brain activity, observed through an EEG in a clinically dead patient with no blood pressure or heart rate, could indicate the soul leaving the body. This brain activity, known as gamma synchrony, is linked to conscious thought and can last from 30 to 90 seconds after clinical death. While some skeptics argue this is merely neurons firing their last, Harmeroff proposes it may represent consciousness departing the body, requiring less energy than other brain activities. This hypothesis aligns with a study by Dr. Robin Carhart-Harris where MRI scans showed no brain activity while subjects under the influence of psilocybin reported vivid experiences. Harmeroff suggests this indicates consciousness may operate on a deeper quantum level. The idea is that consciousness could be a low-energy process occurring through quantum vibrations within neurons, possibly explaining both the end-of-life brain activity and the psilocybin-induced experiences. Quantum mechanics, the branch of physics dealing with the behavior of particles at the smallest scales, introduces concepts that challenge our classical understanding of reality. One such concept is quantum entanglement, where particles become interconnected in such a way that the state of one instantaneously influences the state of another, regardless of distance. Applying this to consciousness, some researchers propose that quantum processes within the brain could be responsible for the emergence of conscious experience. The orchestrated objective reduction, OR theory, developed by Dr. Stuart Harmeroff and physicist Sir Roger Penrose, posits that consciousness arises from quantum computations within microtubules, structural components of neurons. According to this theory, these quantum processes are orchestrated and collapse in a way that produces conscious awareness. If consciousness is indeed rooted in quantum processes, it raises the possibility that it might not be entirely confined to the physical body. Quantum states can, in theory, persist beyond the death of the organism, suggesting a form of consciousness that transcends physical demise. The idea that consciousness could continue after death has profound implications. It challenges the materialistic view that consciousness is solely a product of brain activity and opens the door to concepts traditionally associated with spirituality and metaphysics. Moreover, If consciousness is a quantum phenomenon, it might be subject to the same principles that govern quantum particles, such as superposition and entanglement. This could imply that individual consciousnesses are interconnected at a fundamental level, forming a collective consciousness or universal mind. However, it's essential to approach these ideas with scientific skepticism. While intriguing, the hypothesis that consciousness persists after death due to quantum processes remains speculative and requires empirical validation. As we ponder the possibility of consciousness transcending death, we find ourselves at the crossroads of science and spirituality. The quantum soul hypothesis invites us to reconsider our understanding of life, death, and the nature of reality itself. In our next segment, we'll explore the concept of time and its mysteries, examining how our perception of time shapes our experience of the universe. As you drift into sleep, consider the possibility that your consciousness is part of a vast, interconnected web, transcending the boundaries of time and space.